At 0314, inside the Combat Information Center of USS Spruance, a junior petty officer studying a waterfall display noticed something that changed the morning. Not a contact, not a track, a gap. A pocket of acoustic silence in the Gulf of Oman where there should have been ambient noise. Biologic scatter, shipping traffic, thermal clutter from the warm surface layer colliding with cold, deep water. Instead, 14 nautical miles southeast of the Abraham Lincoln Carrier Strike Group, the ocean had gone quiet in a way that only one thing in the world can produce. Something was hiding there, something diesel-electric, running on batteries, moving at 4 knots to minimize cavitation, something that had been stalking the strike group for 6 hours. The USS Abraham Lincoln is not the kind of ship that sneaks up on anybody. CVN 72, a Nimitz-class nuclear-powered aircraft carrier, displacing over 100,000 tons at full load, with a crew of roughly 5,000, is visible on satellite imagery from orbit and audible on sensitive hydrophones from 200 miles. She entered the U.S. Fifth Fleet area of operations weeks ago as tensions with Tehran escalated past the point where diplomats were still pretending to have solutions. Her air wing, Carrier Air Wing 9, carries F, A-18E and F, A-18F Super Hornets, F-35C Lightning IIs from VMFA, 314, EA-18G Growlers for electronic attack, and the E-2D Advanced Hawkeyes that serve as the nerve center of the strike group's airborne awareness. She is, by any measurement, the most dangerous collection of aviation power currently floating anywhere in the Arabian Sea. What she was facing was Iran's most capable underwater asset. And capable is a relative term that deserves some context. Iran operates 3 Project 877 Kilo class submarines under the Iranian designation Tariq class. These boats were built in Russia and delivered to Tehran in the 1990s. Each one runs 74 meters long, displaces roughly 3,000 tons submerged, and carries 6 torpedo tubes in the bow. The Russians gave them a nickname, Black Hole Submarines. The anechoic rubber tiles bonded to the exterior hull, absorb active sonar returns, and dampen outgoing acoustic signatures so effectively that Western navies spent years developing detection techniques, specifically designed around their characteristics. In the right conditions, a kilo running on electric motors is genuinely difficult to find. Think of it less like a submarine and more like a piece of the ocean that has decided to move with purpose. The tiles do not make it invisible. They shrink its acoustic cross-section to the point where distinguishing it from ambient thermal and biological noise requires sustained, multi-sensor attention. That is precisely what the Abraham Lincoln's ASW screen is built to provide. The conditions in the Gulf of Oman were not quite right for Iran. They never are, when the other side already knows you are there. 3 days prior, a P-8A Poseidon maritime patrol aircraft operating from Al Dhafra Air Base in the UAE had dropped a pattern of AN/SSQ-53G sonobuoys across the suspected transit route. The Poseidon's AN/APY-10 multimode radar had flagged a brief snorkel mast at the edge of its detection range. The contact lasted 11 seconds before it disappeared. 11 seconds was enough. That single data point, fused with shipping lane movement analysis and signals intelligence gathered from Iranian naval communication intercepts, allowed fleet analysts to build a probabilistic track. The kilo wasn't a surprise. It was a variable with a known value. The doctrine Iran was attempting to execute has been refined over 30 years of wargaming against the carrier threat. The idea is elegant in theory. The Persian Gulf and its approaches create a natural choke environment. A submarine running extremely quiet on batteries, using thermal layers and the acoustic noise of heavy commercial shipping as cover, could theoretically position close enough to a carrier to fire torpedoes before defensive helicopters could react. It requires patience. It requires exceptional crew discipline. And it requires that the carrier's ASW screen has a gap somewhere. The Abraham Lincoln's ASW screen had no gaps. 0317. The Spruance's contact evaluation reached the carrier's tactical action officer. Classification: probable submarine, bearing 142, range 14 nautical miles. Profile consistent with Project 877 Kilo class, running on electric drive, slow. The tactical action officer picked up a phone. 3 words: launch the Romeos. The MH-60R Seahawk helicopter is what happens when engineers spend 40 years solving the specific problem of finding submarines that do not want to be found. The aircrews call it the Romeo, and it carries one of the most sophisticated acoustic hunting suites ever fitted to a rotary wing aircraft. Its AQS 22 Advanced Airborne Low-Frequency Sonar, known as ALFS, is a dipping system. The helicopter descends to low hover, lowers a sonar transducer into the water on a cable, and listens. Not just for propeller sounds, for pressure anomalies, thermal disturbances, acoustic shadows. The returns feed into onboard processing systems that classify contacts with enough fidelity to distinguish between submarine types. It can separate a kilo from a Theta class in the same acoustic environment where older systems would see only noise. 2 Romeos from Helicopter Maritime Strike Squadron 71 lifted off from the Lincoln's flight deck within 4 minutes of the alert. A third followed 90 seconds later. They spread in a triangulated pattern toward the contact bearing, flying nap of wave to minimize radar exposure, maintaining radio silence. The crew of the Iranian Kilo heard nothing. They rarely do. 0331. Romeo 1 established dip position 9 nautical miles from the contact estimate. The sonar transducer went into the water. The acoustic picture came back in under 2 minutes. Single-screw diesel-electric propulsion signature. Machinery noise consistent with Project 877 hull. Depth estimate 90 meters. Speed 4 knots. Bearing 138. The Kilo had been crabbing slightly east, angling for a better firing solution on the Lincoln's projected course. Romeo 2 confirmed the track from a second dip point 4 nautical miles offset. Triangulation collapsed the contact position to a circle of uncertainty, 600 meters across. For what was about to happen, that was precision adequate for the purpose. 0338. The Kilo fired. The decision inside that Iranian control room represented the kind of institutional desperation that overrides rational calculation. Command pressure from Tehran, months of preparation, a crew that believed their silence had kept them invisible. 2 Valfager heavyweight torpedoes left the bow tubes in succession. Iranian-produced 533 millimeter diameter active and passive acoustic homing. The targeting solution had been computed against the Lincoln's acoustic signature, which was not difficult to find. 100,000 tons of nuclear-powered carrier generates a distinctive low-frequency signature audible across considerable distances. The Valfager torpedoes are not trivial weapons. Iran developed domestic torpedo production capability in the 2000s after decades of dependency on foreign suppliers. The Valfager is a genuine anti-ship weapon. Against a merchant vessel, or even against a warship operating without layered ASW protection, it would accomplish exactly what it was designed to do. The Abraham Lincoln is not a merchant vessel. 0338 plus 23 seconds. Romeo 1's crew had the fire transient on their acoustic record before the torpedoes had traveled 400 meters. The distinct hydraulic pressure signature of torpedo tube flooding followed 11 seconds later by the launch transients of 2 weapons. Bearing, range, and depth of the firing platform were resolved to targeting quality accuracy within 45 seconds of the first transient. The Romeos did not need permission from Fleet Command. Weapons, free authorization for self-defense of the carrier had been pre-delegated 6 days earlier when the Kilo's transit was first assessed as potentially hostile. Romeo 1 dropped 1 Mach 54 lightweight torpedo. Romeo 2 dropped a second, offset by 800 meters to prevent the Kilo from evading between them. The Mk-54 is the U.S. Navy's standard ASW torpedo for air-delivered engagements. 12.75 inches in diameter. Propelled to over 40 knots by an electric motor fed from a seawater-activated silver oxide battery. Its guidance system combines active and passive acoustic homing, and it was specifically engineered to perform in the shallow water littoral environments where older torpedoes failed. It navigates thermal layers that older weapons would misinterpret. It classifies contacts with enough discrimination to reject false targets, like marine mammals or thermal noise. In the Gulf of Oman at 90 meters depth, against a 7.4-meter target with a strong acoustic signature running at 4 knots, it had nowhere close to a difficult problem to solve. The Kilo's crew had approximately 70 seconds between torpedo launch and impact. In that time, the Iranian captain made the only move available to him: emergency blow, flood aft ballast tanks, emergency full ahead on electric drive. Turn into the incoming torpedoes to minimize his profile. None of it mattered. The Mk-54 that destroyed the Kilo detonated under the keel at frame 34, inducing a whipping stress fracture through the pressure hull that the boat could not survive. The second torpedo was recalled. It was not needed. 0347. The Abraham Lincoln continued northeast at 18 knots. Her heading had not changed. Her speed had not changed. Her flight deck was cycling an E-2D Hawkeye for scheduled launch in 14 minutes. The 2 Valfager torpedoes the Kilo had fired ran for 19 minutes on their terminal homing pattern before their fuel exhausted and they sank. They never acquired a target. The acoustic environment between their launch point and the Lincoln had been contaminated by the MH-60R helicopter sonars operating on similar frequencies, creating enough acoustic clutter that the torpedo's homing systems could not discriminate the carrier from background noise. The Romeos had, in effect, jammed the Iranian weapons simply by doing their jobs. The cost ledger requires examination. Iran expended 1 operational Kilo-class submarine, representing roughly 1/3 of their entire heavy submarine fleet. Replacement cost per boat, at current Russian defense export pricing, approximately $350 million. The boat cannot be replaced. Russia is not selling Kilos to Iran in the current sanctions environment, and Iran's domestic submarine industrial base cannot produce a comparable heavy displacement hull. The crew of 52 did not survive. Iran also expended 2 Valfager torpedoes at an estimated production cost of $1.8 million each. Total Iranian expenditure: 1 irreplaceable strategic asset, 52 trained submariners who cannot be quickly replaced, and $3.6 million in torpedoes that accomplish nothing. The United States Navy expended 2 Mark 54 Mod, 1 lightweight torpedoes at approximately $870,000 each, and the aviation fuel for 3 Mark 60R sorties. Total direct cost, roughly $2 million. The strategic return on that $2 million was the permanent removal of Iran's most capable undersea threat from the order of battle, a reduction of the Kilo fleet from 3 boats to 2 under circumstances that demonstrate clearly to naval planners in Tehran that the remaining boats face the same risk, and a data set of Iranian submarine tactics, acoustic signatures, and crew decision-making that will inform American ASW planning for years. The Persian Gulf is not a sanctuary. It never was. Iran spent 3 decades and considerable treasure building a submarine force designed around the premise that shallow water acoustic complexity and the threat of asymmetric attack could neutralize American carrier operations in the DEC region. What the Gulf of Oman confirmed in the space of 33 minutes is that the complexity works in both directions. A hunter who has been hunted from the moment it left port, who is tracked by assets it cannot detect, who fires weapons into a sensor environment that was shaped specifically to defeat them, is not a hunter at all. It is a problem with a predetermined solution. The Romeos returned to the Lincoln at 0412. They were on deck, refueled, and ready to cycle again in 38 minutes. Somewhere beneath 90 meters of dark water, the seafloor of the Gulf of Oman now holds what Iran's naval command spent decades building, and Tehran's generals spent years threatening to use. They came looking for a carrier. They found a hunting ground that had been prepared for them long before they arrived. If you found this breakdown valuable, Subscribe and share this video. The engagements that never make the news are the ones that define who actually controls the sea.